Okay, so example 2. We've just done 2 adding problems. Now we're going to subtract, right? What do you remember? In order to add or subtract fractions, we must have common denominator. So, what we did right before we left class yesterday is we worked on the common denominator for this problem, didn't we? Remember, always factor those denominators to help you decide the common denominator. So, x squared minus 2x, and x factored out, right? So we had x minus 2, 2x minus 4, a 2 factored out, so we have 2x minus 2. Now, how did the common denominator work? Start by looking for anything that is in common. And what do we have in common here? X minus 2. So, to represent that x minus 2 in common, a single x minus 2 goes in my common denominator. Now, once those x minus 2's are gone, what's the leftovers? An x and a 2. And x times 2 is better said as 2x. So we made our common denominator 2x, x minus 2. Okay, so now we've got to actually get that common denominator, right? So look at your first fraction. It was x minus 2. How do we get to the common denominator of 2x, x minus 2? Multiply by 2. If I multiply my denominator by 2, we got to multiply the numerator by 2. How talented do you feel? Do you want to go ahead and multiply 2 times x plus 2? What is 2 times x plus 2? Yep, you're going to distribute it. Yeah, when we take that 2 times x plus 2 and distribute it, it becomes 2x plus 4. Important to notice, what kind of sign's in the middle? That's a subtraction sign, right? That's going to matter in our next step. Okay, second fraction. It's 2x minus 2 is my common denominator. We had 2x minus 2. What are we missing? An x. So, if we have to multiply by x on bottom, got to multiply by x on top. Again, how talented are you feeling? Can you go ahead and multiply by x? X times x makes it x squared. 2 times x makes it plus 2x. Okay. We have that common denominator. So let's put this together as one fraction. So my denominator is going to be 2x, x minus 2. On top, remember that we are subtracting. So, what do you notice? 2x minus 2x over here are going to cancel. Okay? What about this 4? Just carries down as is. There's no other whole numbers, so I'm just going to put it as a 4. What about x squared? It just stays, but what does it stay as? Minus x squared or negative x squared, because that x squared is in the second fraction. It's being subtracted, right? In this case, it's being subtracted from no other x squareds. So it's like nothing minus x squared is negative x squared. Yes? Yes. Reminds me, I need to put more pencils in my loaner thing. Okay. Now, you've got a 50-50 shot. You can always stop here and just hope you're done. But I would not encourage that. I would encourage you to get in the habit of, we need to see what we can do about factoring. Now, I would say, the way we ended up writing this, is it a bad thing if I say the top is backwards? What are we used to seeing? X squared first, right? So if we think about this in the other order, if we put the x squared first, it's what? negative x squared plus 4. And if you wrote that, that's fine. But here's what I'm going to suggest. We've had it happen before. When there's a negative on the x squared, what do I usually suggest you factor out? A negative. There's nothing else in common, but we're going to need to factor out a negative because there's something that, I'm going to be up front, there's something that's going to cancel. This is a necessary step. This is not me just practicing factoring. Okay? So please follow along. So I'm going to factor out the negative. And when I factor out the negative from negative x squared plus 4, negative x squared becomes positive x squared, plus 4 becomes minus 4. Still over the denominator, 2x, x minus 2. Right, I'm running out of room. I have one more line I wanted to write here. Yikes. Okay. By factoring out that negative on top, what do you know about x squared minus 4? 2 parentheses? Yes? And that's important because especially, take a glance at the denominator. Do you see where we're going with this? We have canceling coming. So I'm going to keep that negative out front. Gosh. X squared minus 4 is going to break into x and x. 4 breaks into 2's, and the signs are plus minus. Now, officially, again, I didn't leave myself the right amount of room here. On the denominator, I have 2x over x minus, or 2x times x minus 2. All of that to say, what happens? Yeah. X minus 2 cancels with x minus 2. And what remains? Negative of x plus 2 over 2x. And we're not going to cancel those 2's because this 2 on top is married to the plus x. This 2 or x we could cancel from the bottom, but we don't have another plain 2 or x on top to cancel with. Yes? If you want to take the parentheses off, you would have to redistribute the negative back in and say negative x minus 2, which is acceptable in my mind. You know, if you want to say negative x minus 2 over 2x, that's fine. What you can't do is drop off the parentheses and just say negative x plus 2. Right, yeah, x plus 2 doesn't add, so it has to stay x plus 2. Okay. Okay, well, I still have to do variable restrictions. So I'm not going anywhere yet. What about variable restrictions, folks? Denominator equals 0. And when we're adding and subtracting fractions, the easiest thing to do is to just take your factored common denominator and set it equal to 0. So what am I setting equal to 0 in this case?
2x equals 0.
Yeah. 2x equals 0. And x minus 2 equals 0. So if 2x equals 0, divide by 2, right? And x cannot equal 0. If it's x minus 2, add 2, and x cannot equal 2. So x cannot equal 0 and 2. Okay? Questions? Yes?
Because I've kind of been struggling with this a little bit, just the finding I'm trying to remember the word for it. My brain is not functioning today. The denominator equals 0 thing.
The restrictions on the variable?
Okay. What are I know we were supposed to already learn this, but can you just run me over the steps of finding those again? Because
It's basically, the idea here with restrictions on the variable is in a fraction, a denominator cannot equal 0. That's the key that we're working off of. A denominator cannot equal 0. And so by setting each part of the denominator equal to 0, that's helping me find what would make my denominator 0. And so what do I have to say? Okay, x cannot be. And so in these cases, like if you just look at your common denominator, I'm taking each factor. So 2x is a factor. I set it equal to 0. X minus 2 is a factor. I set it equal to 0.
So we find it based on the common denominator that we find, not the original.
You would find the same values if you use these unfactored forms, but it's just easier and more efficient to just use the common denominator. Okay? Anything else? I am going into B. B is the other one I was going to do on this lesson, or on this section. So you ready for B? Okay, I have to zoom out anyways to... Okay. What are you doing first on B? Yeah, we've got to factor that denominator, don't we? In order to get a common denominator, we have to factor. So in order to factor this denominator, well, what do you know about x minus 2? It's x minus 2, isn't it? What about x squared minus 3x plus 2? What are we going to assume that probably does? It looks like it should go into 2 parentheses, so always assume it does. X squared breaks into x and x, multiplying to be 2, adding to be negative 3. Yeah. 2 times 1 is 2. If it adds to be a positive, same sign. Excuse me, if it multiplies to be positive, same signs. If it adds to be negative, both negative. So minus 2, minus 1. Leads me to believe we might be on the right track because there's something in common, right? Okay, so I've got things factored. Let's talk common denominator now. What's in common that has to go in my common denominator? X minus 2. Both fractions have an x minus 2 in the denominator. So that's part of my common denominator. Anything else in common? Well, okay, so there's nothing else in common that we have to grab, but leftovers? There's a leftover x minus 1 that we have to grab, isn't there? So my common denominator is going to be x minus 2 times x minus 1. I tend to write it out for 2 fractions worth. If you'd rather go ahead and put it as 1 fraction here, you can, but whoops.
So why is that considered a common denominator if the first fraction doesn't have an x minus 1?
Because we're going to have to give it an x minus 1 to get a common denominator. It's kind of like if you're trying to add, say, 1/2 and 1/8. You can't add 1/2 and 1/8.
Right.
So we would have to take that 1/2 and multiply it by 4 to get that common denominator.
So we're multiplying the first one by x minus 1.
That's our next step. Yep. Yeah, so my question is going to be, my first fraction currently has a denominator of x minus 2. We're trying to get it to this common denominator of x minus 2, x minus 1. So what do I need to do? Multiply by the missing x minus 1. Whatever I do to the denominator, we're doing to the numerator. How confident are you? Can we go ahead and multiply x minus 1 and x plus 3? FOIL, yep. Important to notice. So if I FOIL x times x, x squared, outsides, x times 3 is 3x, insides, minus 1 times x is minus 1x. So what's 3x and minus 1x? 2x. Are you guys okay with me? If I go ahead and say plus 2x, I just went ahead and put my outsides and insides together. And then last, minus 1 times 3. Minus 3. Now, if you have it written out as x squared plus 3x minus 1x minus 3, that's okay. Clean it up in the next step. Okay, got my minus. My second fraction. How do we get the common denominator? It's already there, isn't it? So if my common denominator is already there, what do we have to do to the numerator? Nothing, just carry it down. 6x minus 7. Okay? This? No, I'm not going to go back and factor it right now. I don't want to go back and factor it because I need to put these two fractions together. So I have two fractions being subtracted. And so now we're going to put it together as one fraction. What's my denominator? X minus 2, x minus 1. Notice, what kind of problem is this? This is a subtraction problem, yes? It may sound dumb of me to repeat that, but someone's going to forget it. So I'm trying to remind us. Okay, look for like terms. What's x squared go with? Nothing. So it just carries down as x squared. 2x minus 6x. So what's 2x minus 6x? Minus 4x. Minus 3 minus negative 7. You got that? Minus 3 minus negative 7. Do you need that visual? Minus 3 minus negative 7 is really negative 3 plus 7, which is plus 4. Now that we have it together as one fraction, this is where you want to try and factor. Because this is when we want to cancel. Don't try and cancel. This is a common mistake to make. Trying to cancel up here before we ever put the fractions together. You don't want to cancel till you get your fractions together. Well, you'd lose your common denominator if you start canceling. Before we get our fractions together, if you go back and factor this, yeah, that x minus 1 is going to cancel. But that defeats the purpose because then we've lost the common denominator. And I'll see some of you do that. That's a typical mistake in this lesson. So, okay. So what are you guys doing now? We're factoring the numerator. What do you know about x squared minus 4x plus 4? X and x. Multiplies to be positive 4 and adds to be negative 4. Minus 2 minus 2. Denominator was already x minus 2 and x minus 1. What just so happens? X minus 2's cancel. I'm left with x minus 2 over x minus 1. Okay. Restrictions on the variables. Are there any? Of course. There's variables in the denominator. So, again, my recommendation is using the common denominator. That would cover everything. So what's in my common denominator? X minus 1, x minus 2. So, my x cannot equal 1 and 2. Okay. we getting an idea of how to add and subtract fractions? Okay, it takes work. It takes practice. I'm not going to deny that. So you're going to have to work at to, get it all figured out. And more than anything, when you try to multiply and divide one problem, then add and subtract the next problem, you really have to have straightened out which is which. And that will be a big thing we'll have to worry about when we're reviewing for the test. Okay, as we get ready to flip to the back side, I want to talk about complex fractions yet. So if you've happened to peek at the back side, you'll see its ugliness in fractions, isn't it? Okay, so those are called complex fractions. A complex fraction is a rational expression that has at least one fraction within the fraction. So when we talk about fractions within fractions, those are complex fractions. Now, we have some options here. And here it mentions to work with complex fractions, look at all the denominators within the problem, and multiply the top and bottom of the fraction with their common denominator. And so, it's probably what we're going to do with the idea of being able to clear out fractions then. And I go back and forth on how best to teach this, so that's why I kind of have to stop and think here. So, my plan is to look at A and B. If I remember, C gets pretty ugly, if this is the one I'm thinking of. So,
We want to see a C on the text.
no. Okay, so A, 1 over x plus 1 over y, all over 1 over y plus 1. So, traditionally, how do we get rid of a denominator? By multiplying, right? Because a denominator is dividing by something. So to get rid of a denominator, we want to multiply by something. And so that's one option of how we can handle this. Now, think about just the top two fractions. Well, actually, I guess you want to think of any fractions, really. But what kind of common denominator would you have with these top two fractions? There's an x and a y. Smush them together, x times y, right? xy. Now, would a common denominator of xy, does that also take care of the bottom? Yeah. On the bottom, we really only need a common denominator of y. But here's the deal. We have to have a common denominator all over that we're thinking about. Now, we're not actually going to get a common denominator, but we're going to multiply by that common denominator. So, if I say xy, does that cover all of the denominators shown?
Mm-hmm.
Yes. So what we're going to do is we're going to multiply the top of the big fraction by xy. What I do to the top of a fraction, we do to the bottom of a fraction. And what you need to realize is by multiplying by xy over xy, xy over xy is something over itself. So we're just multiplying by 1 is all we're doing here. So we're not changing the value. Now, the key is this xy is going to have to distribute. We're going to do xy times 1 over x, xy times x over y. Down here in the denominator, xy times 1 over y, xy times 1. I'm debating the easiest way to write this. I think on this first one, it might be easiest if I write it out to show what's happening. What I'm doing is I'm writing out my original problem, but I'm kind of leaving some spaces because what I want to show you is what happens when we multiply by xy. So the idea is on top we're going to have to take xy and multiply it by 1 over x, yes? What is xy itself as a fraction? How do you make anything a fraction? You put it over 1. So the idea here is we're going to say xy over 1 times 1 over x. We're going to have to do the same thing with every part. So xy over 1 times x over y. In the denominator, xy over 1 times 1 over y. And lastly, it's xy over 1 times 1, but I really don't need a fraction there, do I? I just got in the habit of putting it over 1. So we're taking that xy and we're multiplying by everything. And again, the whole point is to clear the fractions. I promise this will look nicer here in a moment. You just have to give me a moment. Okay? So, first one, xy over 1 times 1 over x. What happens here? What can cancel? An x can cancel, yes. And if an x cancels right here, what remains? Y over 1. Well, and I don't even think about the ones, honestly. Because if we're doing y times 1, that is y. 1 times, technically an invisible 1 is 1, right? What is y over 1? Y. So I would just say on top that this is y. So I was going to put off to the right, decide against it. Plus. Okay, look at the next piece. What changes? Or what cancels? Y cancels with y, correct? So if y cancels with y, and again, technically those become 1s. But what remains on top? X times x, which is x squared. What remains on bottom? 1. What's x squared over 1? X squared. So my numerator, instead of being that ugly 1 over x plus x over y, just became y plus x squared. Do the denominator. It was xy times 1 over y. So when we do xy times 1 over y, what happens? The y's cancel. What remains when the y cancels? X. You can say x over 1 if you want, but you're catching on to the fact that x over 1 is just x plus. Now in this last part, it was xy times 1. And I put it over 1 out of habit here, but is there anything to worry about canceling? No. I mean, if you want 1 to be a fraction, it's 1 over 1 if you want to go there. But don't overthink this. What is xy times 1? Xy. Because when you multiply by 1, it stays the same, right? Okay. Our directions were to write this as a simpler form. Is that simpler? Yeah. It's a simpler form. The point is we no longer have fractions within fractions. Okay? To me, this is an acceptable answer. What's the other option we could do here? I guess I probably should, before I boxed it, talked about that. Is there any factoring that could be done? Technically, what do you notice about the denominator? They have a what in common? An x. If we factor that x out, x divided by x leaves me with 1. xy divided by x leaves me with y. The denominator, or the numerator, y plus x squared, is y plus x squared. Notice there's no factors in common. So that's one of those things where that is an equivalent answer, but it's not like anything cancels that you could actually do anything with. Okay, so the whole thing was here, when we started this problem, we found a least common denominator. That's what that xy was a least common denominator. And we take that least common denominator and we multiply it by all terms in the numerator, all terms in the denominator. Are you okay with what I did there? So, kind of. I'll be honest, I'm teaching it slightly different than I have in the past, but I think it makes it a little bit easier. I don't know. Okay, let's try B. Now, realize here on B, can you tell where the main fraction line is? Yeah. And sometimes that main fraction bar is extended a little longer. It just wasn't on this one. So that's x over 1 over x plus 1 over y. Okay. Look for an overall least common denominator. xy. So right here, we have an x and a y, so that'd need a common denominator of xy. On top, it's an x. We don't need to worry about a common denominator here. So, for our least common denominator, we're going to think xy. What does that mean I need to do with that xy? We're going to have to multiply it by the bottom of the fraction, right? Because that's where our fractions are. But whatever you do to the bottom of the fraction, so even though there's no fractions on top, seems kind of silly, but we're going to multiply the top by xy. And it's just because we have to be equal. We have to be fair. What we do to the top, we do to the bottom. So, I'm going to kind of write this out like last time to help you guys see it. We have x on top. Because we had an x here and a y here. There's nothing in common between x and y, so we just multiply them together. If there's nothing in common, it's just multiply together. Kind of like if you were trying to add 1/2 and 1/3. 2 and 3 have nothing in common, so 2 times 3 is 6 would be our common denominator. Okay? Okay, so what am I going to do with each of these pieces? I'm going to take xy and multiply, right? So I'm going to multiply by xy on top. On bottom, I'm going to multiply each term by xy. That's me essentially trying to show you that we are distributing. So, on top, it's x times xy. What is x times xy? X squared y. So x times x makes it x to the second, and then the y tags along. Okay, in the denominator, when I multiply 1 over x times xy, you guys want the visual? What is xy? It's xy over 1. Can we cross cancel? Yeah, you want to, right? We can cross cancel a x. So we cross cancel an x. What remains? Y. That's nice. You could say y over 1, but you guys have learned that we just need to say y. Second one, if I multiply x over y times 1 over y. Excuse me, xy times 1 over y. Think of it as xy over 1 if you want. He says take out the y's. Y's cancel, what remains? X. Anything we can do with this answer? Yeah. Y plus x is married, so the only thing that will cancel with a y plus x is another y plus x, or x plus y. On top, it's all multiplied, so that's there. Okay, we may have to talk on Monday a little bit more. I feel like they maybe put some in your homework with just numbers, if I recall. I'm kind of out of time today. But, so, do the homework. Lesson 8.5. I believe it has a due date of Monday on it. Okay? Come back with your questions on Monday if you have any. Was it your class we talked briefly about when the test might be? Yeah. I haven't decided. I am in limbo about when I want to put the test. And there is a chance it could be as soon as at the end of next week. And I say that because there's also, I don't know, 8-6 might only take us one day. I don't know. I'm kind of torn about how I want next week to work. So there is a chance the test could come as soon as the end of next week. There's a chance I could push it into the following week. I haven't decided yet. So. But do make sure you get the homework done. Lesson 8.5 in Math Excel.